Hi, tonight our video is on discrete and continuous graphs. So here we have a graph of people's height and weight based on gender. Alright, so the blue dots represent the males and the red dots the females. Now this is an example of what we would call a discrete graph. Okay, and a discrete graph is when you have a graph that shows a set of separate, non-connected points. And usually when we talk about like individuals, or we're talking about something discrete like the number of people that attended a baseball game, okay? And let's say that we were going to make a graph of all the different attendance numbers at 10 Padre games. Well, each graph would be an individual point that would not be connected to any of the other points, because each attendance would be a number by itself. And you couldn't say that, you couldn't connect them and say it's continuous in that, you know, how many people attended, you know, in between game 1 and 2. Well, there is no such thing. There's, you know, each individual point has its own discrete value that's not connected to any other. Okay, here we have a graph that's an example of a continuous graph. Unlike a discrete graph, a continuous graph, there is meaning between the points. For instance, here this graph shows the temperature of heated water. Okay, and so along the horizontal axis we have time in minutes, and along the vertical axis we have the temperature of the water. So you can see that as time progresses, that the temperature of the water increases. Okay, and since it's continuous though, we could pick any point on this graph in between all the other points, and there would still be a value connected to that part of the graph. So let's say I wanted to know, you know, what would be the temperature of the water after 2.5 minutes. Well, I would find 2.5 minutes on my horizontal axis, and then I could go across and I can get an approximate value of what the temperature of the water was at that particular moment in time. Okay? So again, this is a continuous graph where every point along that line has meaning. Okay, now here's an example of a discrete graph that shows the dots being connected. And so I wanted to point this out because oftentimes we'll see graphs like this, and and the lines there are meant to show a trend, but there is no value in between these points. So this is the average attendance per game for, I don't know, let's say it's a baseball team, and in the year 2000 this baseball team averaged around 31,800 per game. And then the following season they averaged around 29,600 per game. Okay, and then in the season after that it went down a little bit, and then it went up again, and then in 2004 they averaged around 31,400. Okay, so these are 5 discrete points. And this is a discrete graph, but the line was shown just to show a trend. So the trend shows that the attendance decreased between 2000 and 2001. And it decreased again to 2002. It rose a little bit in 2003, and it increased in 2004. But you can't pick a point in between and say, oh, the average attendance between the year 2000 and 2001 was such and such. There's no such meaning, because each season stands on its own. So again, this is a discrete graph, and don't let the lines fool you. They're just there to show a trend. Okay, here we have a graph that appears to be continuous. Well, let's see what the graph is talking about. It's talking about the growth of orange trees. And so our horizontal axis is number of days. So this is time. As time goes on, the trunk circumference is being measured for the trees. And we can see that as time progresses, that the tree is growing and the circumference of the trunk is increasing. Okay, this is a continuous graph. Because every point along this graph has meaning. I can estimate what the circumference of the orange trees were after 250 days. I can come over here and I could get a point and go across and say, all right, well, the approximate circumference was 50 millimeters. I can go over, if I want to know, after 1,200 days. Okay, I could find that point on the graph and go over and say, okay, well, the circumference was about 150 millimeters. So every point along this graph has meaning because the tree is continually growing as time goes on. Okay, this is a bar graph, and it is graphing students' test scores or test marks in percent. All right, and so these bars represent individual students. So what kind of graph do you think this is? Do you think it's discrete or continuous? Well, if you said discrete, you are correct. This is a discrete graph because each student is an individual and their scores are not connected to one another. This just shows, I guess a trend of how the students did in the class. And it doesn't necessarily even have to be a bar graph. These could be points. One student scored 85, another student scored 65, another student scored 75, and another 85. So this is a discrete graph. We couldn't find a point in between. If we connected these, it would have any point in between these connections would have no meaning. All right, we have a couple more graphs. Go ahead and write down what you think these are, if they're discrete or continuous. Pause your video and check the answer. Welcome back from pausing the video. Let's look at the graph on the left. This graph shows bus trips and it shows number of people. All right, so this graph shows 6 bus trips and the number of people that rode on the bus for each trip. And notice that they are individual points and they're connected with a dotted line. So what did you think this was? Discrete or continuous? Well, if you wrote discrete, you are correct. So it looks like the dotted lines were there to show a trend or a pattern, kind of like the baseball attendance graph. But the points in between have no meaning. There's no such bus trip 2.5. There's no such bus trip, 5.25. No such thing. You just have 6 different bus trips, 1, 2, 3, 4, 5, 6. And each trip has its own population of people that rode on it. Okay, what about the second graph on the right? Here we're looking at the distance traveled in kilometers over time in minutes. Okay, this is an example of a continuous graph. Because as time goes by, okay, this graph is showing that distance is being traveled. And you can pick any point along this graph and it would have meaning. So if I wanted to know how far, this graph showed how far what distance was traveled after 100 minutes. I could find 100 minutes and then go across and find a corresponding value for the 100 minutes. Okay, so every point along this graph has meaning. So how'd you do? Okay, well, very good. Thank you for listening, and we'll see you tomorrow.